All right, welcome back. We're going to do section 3.11. And this one is going to be called product estimation with mixed numbers and fractions. So we're going to call product estimation with mixed numbers and fractions. All right, so this one is similar to our previous episode where we did fraction multiplication, except we're going to be combining our style of estimating fractions in with this to make it much easier. So this is going to be useful for, say again, we're going to use a recipe, and a recipe calls, oops, that's a terrible calls, for 1 7/8 pounds of potatoes. But we're cooking for a banquet, and at the banquet there's going to be 40 people. Now, this is going to be a really good opportunity for us to estimate, because we're going to be using this larger amount of potatoes and with all of the people that we have. And we don't need to know exactly the specific pounds per person that we need at the end, but instead we're going to estimate the whole thing. It's even likely that we're doing this maybe at the store or like in a last moment. We have to kind of carry this all in our head. So we're going to take 1 7/8 times 40. Now, if we were going to do this with our old style of multiplication, we would need to turn them into mixed numbers, turn them into improper fractions, then numerator, denominator, and then simplify. And a lot of that is very difficult to do in our head. Instead, we're going to use our common benchmark fractions. To estimate. So let's take a more simple example. Sorry. Excuse me. More simple example before we go back and return to that previous problem. So, for example, say I'm going to estimate the product of these two things. I'm going to go 4 5/6 times 2 1/9. What I'm going to do with each of these numbers is I'm going to look at them and turn them into the common benchmark fraction that works the best. Remember that those common benchmark fractions are 0, 1/2, and 1, which makes things much, much easier to work with. Watch as I do this quickly. 4 5/6. Now, if I wanted, I can say, 5/6. Is that closest to 0/6, 3/6, or 6/6? But I can see, that it's already closest to 6 because 5 is only one way from 6. So I can turn this fraction into 1, which gives me 4 plus 1, which is 5. Now I'm going to do the same thing with this one. I have 1/9, and I can ask, is that closer to 0/9? 4.5/9, or 9/9. But I can really see this is 1/9, and it's going to be much closer to 0 because it's only 1 up. So I can say this is like 2 plus 0, which is really 2. So now I have 5 times 2, which is 10. And that's already simplified and good to go. See how easy that was? Let's try another quick example. Let's call this one example 1. Now, of course, this is much easier if you actually remember your common benchmark fractions. It's a bit trickier if we don't. Okay, let's take a look at this one. We're going to say 9/10 times 5/6. Alright, so again, I can do this in my head if I know it, but I'm going to write it out just because it makes me a little bit more comfortable. Oh, I forgot to turn my music off. Sorry about that. My 9/10 here, is it closer to 0/10, 5/10, or 10/10? Well, it's definitely closest to 10/10, so I can really write this as 1. 5/6, is it closest to 0/6, 3/6, or 6/6? Well, it's definitely closest to 1. So now I have 1 times 1, which is 1. 1 time is 1, right? So I turn this whole mess of a thing into 1. And I can even do this usually in my head to save a lot of time. Let's take a look at another example. Say this time I'm going to do 9/10. Oh wait, it's not the one that I'm looking for, sorry. I want to do 7/12 times 10/11. Alright, so I can ask myself again, I know this one is going to be closest to 1 because look, 10 is almost 11. So I can definitely say that's going to be 1. And here, oops, let me move it up. I have 7/12. And this, my gut says that it's going to be in the middle, but I'm going to write them out just to check. It's going to be 0/12, 6/12, or 12/12. Definitely. And 7, oh, my gut was right. It's definitely closest to 6. So now I have 1/2 times 1. And I should know that 1 times any number, it keeps the number the same. So I really have 1/2. And I can also verify this another way, because I can write 1/2 times 1 as 1/2 times 1/1, right? And this would be 1 times 1 is 1, 2 times 1 is 2. So I also get 1/2 this way. But generally, anything times 1 is going to stay itself. Okay, let's go look again at that problem that we had earlier. This recipe issue. We have 1 7/8 times 40. Now, if I look at this 1 7/8, the 7 and the 8 are almost right next to each other. The 7 and the 8, sorry. So I can really turn this into a 1 and add it to the number that it had originally. So I can write this as 1 plus 1, which is 2. So I really have 2 times 40, which I should be able to do in my head, remembering that 0 rule. If I cover up that 0, I have 2 times 4 is 8. Add that 0 back in, 80. Now, I really shouldn't use an equals sign for this problem, because 1 7/8 times 40 does not equal 80. So I shouldn't write it like this. I should write it as it about equals 80, or it approximately equals 80, because this little symbol here we typically use when we estimate, because it says to the person that's reading our paper approximately that we made some changes in it. And for things like cooking like this, approximation is great, because we'll never have exactly 1 7/8 pounds in every helping. Whereas things, if we're working on the Mars lander and we're making sure it lands on a planet, that is something that we would not want to round on, because those are much more specific. If you feel like you've got this, go ahead and be done. I'm going to do 2 more examples using those mixed numbers in case you're still a little bit confused. Okay? Let's look at example 4. Example 4, we're going to use one like this. We're going to say 6 and 1/17 times 4 and 3/5. Okay, so I'm going to round this. 6 I bring down. 1/17, if I need to check I can, but whenever I have 1 up here and a big number up here, that means a really small slice. So I can say that's going to be 0. Times 4, and we've got 3/5. My gut's going to say that's about halfway. Let's look. 0/5, 2.5 fifths, and 5/5. Well, 3 is definitely closest to 2.5, so I'm going to do 4 and a half. Okay, So if I have 4.5 here, now in this case I am going to have to multiply by using my normal fraction styles. So I do have 6 wholes, and here I would have 4 times 2 plus 1 over 2, which would give me 6 over 1 times 9 over 2. 6 times 9 is 54 halves. 54 reduced is 27, because I can divide both by 2. But again, I should use that approximately equal to 27. So sometimes when I do end up with a half, I will need to do my typical style of multiplication. Let's do one more looking at this. Example 5. And this time we're going to do 3 and 3/9 times 5 and 7/8. Alright, so let's take a look. Actually, this isn't going to work because it doesn't show what I wanted to do. Let me change it again. Sorry about that. We're going to do 3 and 4/9 times 3 and 5/8. Okay, so in this case, I'm going to take my common benchmark fractions and turn it down. So I've got 3 times 4/9. 4/9 is going to, I can turn that into a half. So I've got 3 and a half, not times, plus, times 3 and a half, because 5/8 here I can turn into a half. So 3 and a half squared, because they're times each other. So in this case, I'm going to turn them into mixed numbers, or sorry, I'm going to turn them into improper fractions. 3 times 2 . So I've got 7 halves, and I know it's going to be the same thing, so I can just write it again. 7 times 7 is 49 fourths. So there we go. I've got my estimate for those two things. It saved me a lot of time with finding common denominators, but it certainly isn't as quick as when we don't have to go to a half. Hopefully this makes sense. If it does, awesome. If not, come find us, and good luck.